All right, perfect. I'm going to go ahead and get started. Feel free to drop any questions that you have in the question, and I will be happy to answer once the presentation is done. Today, we will be covering the webinar of building performance analysis and optimization for confidential government projects. My name is Mustafa Tamosebi. I'm part of the research team here at Cove. I have a background in civil and architectural engineering. My PhD mostly focuses on building energy systems. Um, with that said, I'm going to start sharing my screen and we can get started. Perfect. First thing that we will cover today is to just talk about the agenda of this webinar. We will have an introduction on how to what are the type of government projects in the AEC industry. Then we talk about privacy and security inside Cove Tool and how it makes it a good choice for your government projects. We talk about an example of a renovation in campus planning study because a lot of the project these days are focused on renovations. Then we get started with how we actually start modeling using Cove Tool. We talk about setting up a project with security in mind, and then we go through how the analysis tool can benefit us when it comes down to renovation studies. And then we talk about load modeling, and then I would be open to any questions that you guys may have. Um, so without wasting any more time, let's dive in right and see what are the common government projects and requirements and challenges involved with those projects. First type of project that we are dealing with when we are working on a government project is buildings in Washington, D.C., such as, let's say, White House, Congress, Library of Congress. For these type of projects, the project owner is architect of capital. For these specific projects, AOC acts as both project manager and designer. So we will have a series of requirements by the project manager and designer that we have to follow and keep in mind. The other type of projects, government projects, are military projects, and those are usually coming from Army Corps of Engineer, Air Force, National Guard, and it covers different type of buildings, industrial buildings, office buildings, training and educational facilities, and in a lot of cases, actually housing for employees of these sections of government. Again, here, government and these part of government act as project managers. So we do have to follow a specific set of requirements. The other type of projects that we may get as a part of government-related project are the ones coming from Department of Veteran Affairs, and those are usually medical facilities, hospitals, offices, and so on. And finally, the last big chunk of government projects are the ones coming from General Service Administration, and they can cover different type of buildings. Again, more commonly used one of them are courthouses, libraries, post offices, customs, and historic preservation type project. So as you can see, we cover basically all kinds of projects and different type of buildings that we may have to deal with when it comes to working on government projects. There are some deliverables, some key requirements about all these projects that we need to keep in mind and consider when it comes to the design of the project. One is the performance. Performance means basically what are the codes that we need to follow, uh, the security of it, if we are to use a specific software to do, let's say, the energy modeling, we want to make sure these are safe and secure enough for us to be able to use for government projects that have some confidential information involved. The other two pieces that are very important when government agencies actually act as project manager is the timeline and the amount of money that is available to us to work with. And these two are usually the ones that engineers and architects have the hardest time um, going about it. Usually timelines are limited and there's working with the available money can sometimes create some problems. A lot of times finding a solution to how we can minimize the amount of time and minimize the expenditure is often important. So we want to take a look at all these four items here today and see how Cove Tool makes it easier for us to take care of all these deliverables and requirements. First item in that list is performance requirements. Performance requirements are becoming more and more critical. Many cities and states have already adopted stricter energy codes, and a lot of states are catching up on that progress. Government projects in most cases have performance requirements matching local energy codes. The chart that you can see on the right side of the screen shows energy use index improved for both residential and commercial buildings as energy codes got stricter over time. So if you compare, let's say 2004 with 2013, we can see across both residential and commercial building, we can notice a 50% EUI reduction. And speaking of cost involved with using green building materials and technologies, the demand for those technologies increases and industry become more skilled at delivering green building. Upfront cost increase in green building are often offset by a decrease in long-term life cycle costs, particularly in case of green buildings that feature high performance facades, let's say, and energy efficient building systems. Um, we also need to be mindful of what is happening as we're going forward. The picture that you see on the left side is a screen capture from White House website, and this is the new requirement. Federal government will look across existing property and during building construction and major renovations to increase water and energy efficiency, reduce waste, electrifying system, promote sustainable locations for federal buildings by modernizing the federal building portfolio to reach net zero emission by 2045, including a 50% reduction in building emission by 2032. So when we actually get started with either renovation or design a new building, we want to make sure that we are accounting for all the new requirements that are being implemented by the government, specifically for federal buildings. Next thing we pointed out in the initial slides is security and privacy. How can we be sure that what we are using and how Cove Tool can keep every information secure and is a good choice for government-related projects? To get into that some more, we want to actually know how Cove Tool is handling projects. Cove Tool is a web app, and web app is basically a software that runs on a web server. Unlike traditional desktop application, which you have to have on your operating system, web app is accessed through a web browser. There are some advantages to using a web app compared to a traditional software. Some of those advantages, one being, let's say, cloud computing and hosting, which this term is used to describe the storing and accessing of data and programs over the internet instead of being limited only to use your local machine. When you use a web app, users can access the application anywhere Cove tool uses this cloud computing and hosting to perform a lot of routine data backups, so you never lose any work that you've done online. It provides you automatic updates, so you always have the latest capabilities and fixes, and you don't have to actually download a new update, and unlike other softwares that you probably worked with. It also gives you unfettered storage space for fast simulation and results. The other nice thing about web apps is the data visualization option that is available to you, which is basically the presentation of data visually to ensure um, you guys as users can understand everything quickly and apply insights into your decision making. Some example of this data visualization is displaying the SDA ASC shadow analysis in virtual environment. Other example could be generating the whole building EUI breakdown, provides you with national average and calendar usage bar graphs, and very comparative reports. Um, Everything is color coded for easier identification. High resolution climate diagrams and building performance reports are other type of data visualization that we provide within Cove tool environment. The other good point about web apps that I wanted to mention is the AI automation and machine learning that we have incorporated into the tool. Artificial intelligence allows computer to execute series of commands, run thousands of operation, and process a ton of data, basically. Machine learning perform optimization without using explicit instruction. It relies on a lot of known pattern set. It also optimizes cost and energy for you. User can test every option quickly and thoroughly, and frankly, leaving knowing that the decision that they made was thoughtful and the results are curated to their specific design. Other nice things about using a web app is how you can integrate other softwares into Cove tool. Let's say an example of it would be the AIA 2030 DDX dashboard that we are using actively within Cove tool. And finally, security and privacy of it, which if we expand, we can see we are using Amazon server, AWS. More than 7,500 government agencies are using AWS. Cove tool uses the highest security setting on Amazon Web Services to host the application and data. In the background of this slide, you can see where are servers of Amazon Web Services located across the world. They are in different countries, and the servers are constantly shifted around for security and optimized capacity reasons. In the US, numerous AWS server sites allow for more stability, and it becomes unlikely for your information to be stored anywhere else. And when it comes to using machine learning, um, even though if we are using machine learning on cost optimization, we are only strictly analyzing options with for your specific project, and we do not reference other projects even from the same firm. On top of everything that I just mentioned, Cove Tool has signed an NDA that covers user data. Each company in our platform has its own encrypted data, and there is no sharing of data between companies. Um, let's now talk about why we care so much about the existing buildings. Um, Basically, half of the buildings that are going to be in use by 2050 are already built. So we do want to spend a lot of time focus on how we can improve the performance of these buildings that we already have. Uh, there is no one process for renovation because of the challenges associated with each type of building and the set of alteration required for different types of buildings. Um, Talking about it in a very high level, typically the first step for renovation or retrofitting process would be just gathering information, followed by evaluation to understand existing condition of the building. Once we know that there is a SWOT analysis that you can do to determine the strengths, weaknesses, opportunities, and threats that you have within the process. Once that's done, it's time to document everything together and then start designing the changes in the building. Um, Furthermore, only if required, some of the elements are demolished and final alterations are built or constructed. So we always want to first get the information that we need, go through the evaluation, document everything, do the design, and then figure out if we need to demolish something or adding some sort of construction to the building in a renovation process. And to start somewhere, energy audits are a good option. Um, Energy audit is basically inspection of building that are useful in terms of energy efficiency. Um, these type of audits give an indication of the building's present situation and usually include things like checking for leaks, examining the insulation, blower, door, and different tests. So we actually get an idea of how the building operates and what are the things that we might want to uh, consider when it comes to doing the renovation or proposing different options. Once we are done with the energy audit, we are going to think about energy efficiency measures or ECMs. ECMs are basically steps you decide on to reduce the energy consumption of the building or the facility that you're working with. These are typically driven by things that you can do to make advancement in technology. Um, by using different equipment, energy consuming devices, and so on to make it sometimes more efficient, cheaper, um, to make the project more feasible for the project owner. ECMs usually include lighting upgrades, insulation, and building envelope upgrades. HVAC equipment upgrades is another very impactful option available to us when it comes to renovation projects. Power upgrades and quality improvement for energy dashboards are other type of ECMs that we can come up with. Now, the most difficult part of the renovation is never the design or the energy analysis, but it's in fact selecting ECMs and optimizing the ECMs or energy efficiency measures that we come up with. People most of the time tend to skip this part just because either they are not aware of the type of significant benefit that they can get by making those decisions, or they just think that renovation budget is not enough for them to go through these steps. Um, Here, Cove Tool helps with pretty much all these reasons. It provides resources and information about how and whys of renovation project. It also enables you to determine options for energy efficiency strategies and the cost-effective options. And it finally optimizes everything for you. So it basically automates a lot of the things that engineers or architects have otherwise have to do, which tends to be very time consuming. There are 6 steps here in this process. Identifying the scope of your project would be the first one. And then when you're using Cove Tool, you want to set up a 3D model that matches to your existing geometry. We want to calibrate the baseline energy model to match the scope of the project we have. And then finally, model the energy conservation measures and find the best bundle. Let's say we come up with 10 different energy efficiency measures and we are wondering what are the best 5 that I can choose that can be most effective for my specific project. So first, we gather all the information that we have together. We create a baseline, and then once we have a baseline, we can basically stack up the energy efficiency measures that we have, run it through an optimization engine, and figure out what would be the best combination of those options available to us. Going through each of these options one by one, alteration can be made to an existing building in various types. They can be related to repairing the structure, which is renovation, or adding new technology like sensors, building systems, or equipment, which is often known as retrofitting. It can also be refurbishment, which is things like decorating, cleaning, and re-equipping. Tenants improvement is also fairly common, where tenant customize the space according to their requirements. Um, Additions to a building are a combination of existing and new construction. That usually means adding a new part to your building. So basically, no matter what the project type is, there are always opportunities for you to improve the efficiency and performance of your building when you're using Cove tool. To just have an idea of how we can set up a project using Cove tool, this is a snapshot of the first page. Once you log in and you're creating a project, this is the first page that you see. You are expected to decide what kind of building you're basically going to do the design and energy modeling for. You can use one type of building from the 8 templates that is available to you, or you can choose up to 3 of them and have a mixed use project. And basically what happens when you select one type of building is we automate a lot of the values based on standards and engineering and architects best practice for that specific type of building. So a lot of the things that you would otherwise have to manually input is automatically being selected for you in this step. Next step would be selecting the location of the building and selecting a name for your project. Specifically for government projects that may have some confidential information about, we may not have the exact address for the building. To tackle that, we can put the address for the closest airport, specifically for government project, and you can select a name that would not necessarily reflect the actual name of the project. So this is the first step that you can get started with your project, having security in mind. Next step, as mentioned, was to match the existing geometry. There are different steps to it. You can use, you can create and develop your model from the existing structure, identify the scope of the analysis related to relative to geometry. So basically, you may have, let's say, a floor plan for your building. You want to be able to bring it in using either a BIM software like Revit, Rhino, and so on, or you may want to build your own geometry from the scratch. We do have a drawing tool, a full-fledged drawing tool that you can basically build everything from the ground up. Or if you're using a third-party software, a BIM software, you can bring your geometry in using a plugin. Next step would be to calibrate the model inputs. Once you bring your geometry in, you must map the parameters of building accurately to reflect the existing condition of the building. These parameters would include envelope properties like R value of the roof, walls, floors, or let's say glazing. what's the HVAC system used currently, what is the air filtration rate, what is the lighting power density and plug loads. We would want to have a good information about how's the current state of the building. Once you get the existing parameter for the building, then you would only be responsible to make those changes and compare those options with what we refer to as a baseline. You can gather all this information with the help of drawings and the specification mentioned by talking to the previous architects, engineer, or by doing a survey if the project budget permits. Utility bills can also be a good resource for you to be able to get an idea of how building performs. Um, but to summarize everything, using drawings, talking to previous owners, architects, engineers, using surveys and utility bills are the best ways for you to calibrate the model that you already have or you're trying to bring into Cove Tool. Next one would be the calibration of it. If you're not sure what are all these parameters that are available for you to change in Cove Tool, some of these values can be automated. Um, a lot of these information can be collected if you visit the site or talk to people that are living actually in the building. But a lot of automation have already put into place when you're using Cove Tool. So if you're not sure about a specific value, you can leave it as is, or there are help articles giving you an idea of what would be a typical range for, let's say, a lighting power density for an office building, and you can use that as a reference. A tricky case can be when you're dealing with a historic building, which are probably built 20, 30 years ago. Most of the initial document is very hard to find. We are, again, offering some assumptions that are available in our help center. The aim should be to collect as much information as possible. However, also to accept the fact that there's always changes during the construction phase that are not reflected in drawings or documentation provided by our architect should be there. That's why it is emphasized to have an energy audit or basic energy survey if, again, it fits within your budget. To figure out what are the energy efficiency measures we have, you have an entire page when you're using Cove Tool that gives you the ability to look into different ECMs that you can apply. Some of them are, let's say, lighting related, HVAC related. You can sometimes reduce the plug loads in the building. You can change the ventilation values and requirements, or any kinds of strategy is something we can do for the building. The option is available for us to try each of these different energy conservation measures and see if they are working for us the way we are expecting them to. Here's an example of how we can change any of these values and see the results. Basically, you can see here we have a building, a large office building. We change any of this value and click on recalculate. And what this option does is basically run the model through quickly through the simulation engine and say, hey, if you are, let's say, changing the wall insulation, this would be your new EUI. If you're changing the daylight and occupant or add occupancy sensor, this is how much you can save. So you can see in individual level how each of the ECMs that you're applying is going to translate into more saving in terms of energy index or the amount of money that you'd be spending on your electricity and gas bill. You have the option to compare your project in different conditions. In this case, I have an existing project versus the same project after renovation. I can see how my UI changed from before to after renovation. Massing comparison is available to you if you basically are in early stages of design or just want to have an idea of how building orientation can impact your EUI breakdown. Um, the other type of comparison that you can make is just comparing different HVAC systems. Um, Changing these systems often results in savings or giving you a better perspective of what works better for this project. And finally, another comparison example that I brought here is the comparison, the EUI comparison for SDA. So Cove Tool brings you the ability to do all these type of comparisons in a much quicker manner compared to traditional ways of coming up with ECMs, see the impacts, try to compare it manually. And finally, once we have a baseline model that shows the performance of the building that we currently have properly, then we can come up with optimization part. With optimization, we have the baseline model, and then we can introduce other options. Let's say I can say I want a wall insulation of R25, while my R value for my current wall is, let's say, R20. We can stack up all the different options that we can think of. And these options can be related to envelope, HVAC, lighting, equipment load, basically any potential ECM that is available to us. You can bring it here, you can set a price for it, and run the optimization engine. Um, Once you run the optimization engine, it provides you with the best bundle that incorporates into it the cost versus energy optimization. As you can see here, I have multiple possible ECMs that I could think of. I added them all here and I run the optimization engine, and it gives me, it narrows everything down to 2 or 3 different bundles that makes the most sense in terms of the cost and the energy consumption. So that's how you can basically prioritize some energy efficiency measures over the other ones. Visualization at the top. There's a visualization at the top as well, where you can use different sliders to parse through the data. For example, if your renovated building is supposed to be LEED certified, you can click and drag the highest LEED point. You can also select the cost premium according to the budget of the project. It'll automatically shortlist bundles pertaining your goal and requirement for the project. You can also perform as many iteration as you want, where you would do one project in 2 weeks, going through all the permutation and combination of inputs and going through them manually. Using Cove Tool, you can do the same and more in less than 15 minutes when you're using optimization engine here. Now let's take a look at a case study that Cove Tool was used for. This is a renovation study for a dorm in sunny Cortland up in New York. This is a $30 million renovation. There are more than 700 different bundles and optimization. We went through all of them and decided that this option, which upgrades LED lights, improve the roof insulation and wall insulation, could make the most sense for this project, and this was applied. So basically narrowing down options from more than 700 options to the one that makes the most sense energy-wise and cost-wise is something that Cove Tool can help saving so much time and providing you with the best possible result when you're using it for, let's say, a renovation study. The other example is Atlanta Central Library. Um, ECMs or different ECMs are studied, and the final result brings down the final result after implementing the ECMs results in more than 30% in EUI reduction, while we increase the SDA, which is something occupants are going to appreciate by 6%. And the glazing area was increased by 13%. So we can see immediately, in this case, for a library, the average nationwide EUI is 98 versus what we have here is something around 35 to 36 for EUI, which again gives us some information about how using optimization engine to come up with the right bundle improves the results of renovation and provide us with what we're expecting for in this example, a government project where we have to work with a specific amount of money and we have limited timeline. Government projects usually require the quickest result and outcome with a limited amount of money. Using Cove Tool, you can make quick decisions, you can run comparisons, and come up with the solution that is going to be more both cost effective and very much time saving for you. With that said, I think I covered most of the points that I wanted to mention. If there are any questions, I would be happy to answer. Okay, yeah. So the question is how we can use the optimization tool. Going back to one of the slides, you basically decide what are the ECMs that you're trying to propose potentially. In this case, I have the addition of occupancy sensor. I have the option of using, let's say, a DOAS system or a VAV system, or the list is long. Once you're actually using the web app, you have the option to select from different options. You can, for as many ECMs that you add here, a new line would be added here. And the optimization engine parsed through all possible combinations. As I mentioned, for that example, we had the option of 700 different bundles. It goes through all these potential options, run through everything, and give you at the first result that you're getting is the one that has the minimal cost and has the best performance in terms of EUI. In case you want to narrow down your search or you just, let's say, want to get 8 to 10 lead points, you can use a bar here to narrow down your selection to the number of lead points that you're expecting, or you can say, I want the EUI of 35 to 40, the maximum. If, let's say, I'm working on a government project that requires a specific performance, you can narrow down everything to the level required by your project and go from there. Was there any other question? Awesome, perfect. Well, thanks again, everyone, for joining this webinar, and I hope you guys have a good day.